Right, welcome to DG300, everybody. Before we start diving into the actual topic of this class, which is software engineering, I'd like to go through a quick review of object-oriented principles and especially how to express them in C++ and more particularly how to express them in modern C++, aka C++11. I know that especially if you transferred in that a lot of college classes still focus on C++98, which is really the first standard for C++, which, however, by now is relatively obsolete. And also I know that depending on how fast your classes progressed in COS 108 and 109, you may not necessarily have seen everything I will show you in here. So please pay attention and contact me if you have not seen or are not familiar with some of the concepts I'll be talking about. But technically, going through your first two C++ programming classes, you have seen this all, or should have seen this all. So let's jump right in. And why do we even care about object-oriented design? And we're going to certainly come back to object-oriented design on a more formal basis as well. But point is that OO is currently the best practice we have and know to tackle complexity in modern software systems. And not surprisingly so, because it's really modeled after how we humans, with our mind and capability of abstract thinking, actually make sense of reality. So it's a good way of doing things. And traditionally, of course, really we haven't employed OO design from the get-go when it came to computer programming, simply because we did not have powerful enough computers to effectively do this. And however, having more powerful computers allows us to solve more complex problems with, however, also at the same time, because otherwise we can't do it, more complex methods. As we found out, and we'll come back to this a little bit later, there was the big, what they call the software crisis in the 1970s, where systems grew so large that not a single person could understand a single concept or the total code base. So in order, as programs grow, they had to stay maintainable, and OO design helps to do that. OO design also helps us to leverage parallelism and harness parallelism because we have nice abstractions that allow us to express parallel concepts quite nicely using object-oriented techniques. And that used to be just as part of the supercomputer domain, but actually it now is also a big part of personal devices. It's certainly not unheard of to have like 4 or 8 core cell phones. So, and all of these things, all of the things that we also talk about in operating systems, really can easily be abstracted into objects and methods, and therefore, even at the systems level, it's a very powerful metaphor. Although at the systems level, we tend to not necessarily use object-oriented languages, but we certainly use object-oriented concepts to design operating systems no matter what. Coming back to that operating system and high-performance computing, supercomputing thing, it used to be common wisdom that OO concepts were too slow in order to implement them on fast systems. But it turns out, and I'll show this to you, that this really is a misunderstanding, and that if you employ OO concepts and use it to solve problems that generally need it, that you actually cannot be faster than what C++ provides you. So overall, OO design matters a lot, and all major frameworks are object-oriented in their nature. So it's a good idea, of course, to fully understand OO and how to express it in various programming languages. In this particular case, however, I'm going to concentrate on C++.